Hello everyone, welcome back. In today's video, we're going to talk about boxplot. So first of all, we're going to import all the necessary libraries. Then here we are having the sample data for the boxplot. There are three categories that we are considering in this example: category A, category B, and category C. For category A, we are going to generate 50 random numbers from a normal distribution from the NumPy library with a mean of 10 and standard deviation of 2. This is for category A. For category B, we are having 50 numbers being generated from normal distribution with the mean of 15 and the standard deviation of 3. Finally, we are having the 50 numbers from the normal distribution with the mean of 8 and the standard deviation of 1 being generated, and these are going to be considered as category A, category B, and category C. After generating the data, we are having the creation of our Pandas data frame. So we are having the data frame function from the Pandas library for the data that we created here. And the name of my data frame is df. Okay, now we would like to set the figure size. In order to set the figure size, we want it to be 8 by 6, and in order to plot a box plot, simply we are going to call the boxplot function from the Seaborn library, and we assign the data to be equal to the df, which is my data frame that we created from the data that we generated in data here. Okay, and basically this is it. And we are going to put a title saying that basic box plot. So basic box plot, this is my title here. I'm having a y label called value, so you see that the y axis label is value. And we're going to call the show function from the Matplotlib library to plot the figure, so to plot the box plot. And you see that here is my box plot: category A, category B, and category C. So these are plotted here simply using the generated data and the box plot function. It's very simple to have that. So category A, category B, and category C. Now, what if we want to have a horizontal box plot? Again, we're going to do all the same thing. So we're going to have the data generation, 50 numbers for category A, the same with B, the same with C, but in the first one we are having the mean of 10 with the standard deviation of 2. Here the mean of 15, standard deviation of 3, mean of 8, and standard deviation of 1. We create the data frame, we plot the figure, set the size, we call the boxplot function. However, in order to change the orientation here to horizontal, we are having this simple line: orient equals h in quotes. So this is going to help me to have a horizontal box plot. So these are the categories now on the y-axis, and these are the values on the x-axis. Okay, so here instead we are having the value label on the x label, so you see that x label is value, and the category labels are here on the y label. However, previously here the value was on the y label, y-axis let's say, and the x-axis was the categories, and here value was on the y label, but here it's on x label. Why? Because basically we are changing the orientation. So now we know how to, first of all, create a box plot, and now we know how to change its orientation and plot a horizontal box plot. Now here I would like to give you a bit more concept about the box plot. So here I would like to also, apart from the boxes that we are plotting here, I would like to have the data points as well. It would be sometimes very helpful to give some idea of how things are shown in the figure and how the data is generated throughout the horizon. So here again I'm generating the data 50, 50, 50. So 50 numbers for category A, B, and C. The mean and standard deviation, they are not the same. we create our data frame here, and we set the size. And I plot my box plot using the box plot function from the Seaborn library. So data equals df, which is the name of the data frame. Then in order to have the individual data points, we need to call the strip plot function from the Seaborn library, and data equals df. And for the sake of simplicity and for the sake of the fact that we would like to distinguish the points, we are going to change the color. I'm going to run the code now. So when we run the code here, we see that the data points are in grayish color. So if I don't have this line, so if I remove this line, this part of the code, when I run, it is going to give me the data points, but here it's very hard to distinguish the data points because they're having the overlap and the color is the same, so it's not easy to trace them. Therefore, I put the color to be equal to 0.26, so it's a grayish color, so it is easier to find the data points everywhere. So now also we learned how to add the data points using the strip plot function from the Seaborn library. We write down the name of the data frame as the data, and for the color we choose a color different from the original colors of the box plot, so we can easily find the data points. And then we are having the title, so box plot with individual data points. Then we are having the y label, which is value here, and we see it here. And we call the show function in order to plot our figure used from the Matplotlib library. So in this video, we learned how to draw a box plot, how to change its orientation to be a horizontal box plot, and how to show the individual data points. Thank you for watching.